Here we have a SAT math problem. Okay, let's go to the question. The circle above in the xy plane is centered at the origin O, and the coordinates of points A and B are also shown. What is the area of the shaded region? Okay, here we have to find the area of the shaded region. So the idea to get the area of the shaded region is we have to consider the shaded region as sector, that is a part of the circle. Okay, if I want to find the area of a sector, there is a formula, that is theta divided by 360 degrees times the area of the circle, that is pi r square. So here we need the value of theta. Theta is the central angle of the sector. That is, the central angle is over here. And to get the area of the circle, we need the radius of the circle. So we need two things. One is the central angle of the sector and radius of the circle to get the area of the shaded region over here. Okay, now to get the central angle of the sector, let me draw a vertical line from this point to the x-axis over here. And also let me draw another vertical line from this point to the x-axis. Since both of them are vertical lines, we have right angle over here and here we have right angle. Let me say this is point C and this is point D. Okay, now let's consider the right triangle OAC over here. In this right triangle, to get the length of this leg OC, we have to consider the x-coordinate of the point B over here. That is -1. But when I consider the length, we have to take this x-coordinate as a positive value. So there is a length of this OC is 1. That is positive value of this one is just 1. And to get the length of this leg, there is a vertical line segment. We have to consider the y-coordinate of this point, that is square root of 3. Okay, now let's assume the hypotenuse of this right triangle as k. So here OB is the hypotenuse because it is opposite right angle. Now we can use Pythagorean theorem in this right triangle to get the length of the hypotenuse. That is, the square of the hypotenuse equals to sum of the squares of other two legs. That is square root of 3 the whole square, positive 1 square. I'm getting k square. Here this square root and square will cancel. I'm getting 3 and 1 square is just 1. Then we get k square equals to 4. Now to get of the exponent 2 over here, we have to take square root on both sides. Then the square root and square will cancel out. Then I'm getting k equals to square root of 4 is 2. Usually when we take square root on both sides of an equation, we consider positive or negative sign for this square root. But here k represents the hypotenuse. So the length of the hypotenuse can never be a negative value. So we don't consider positive or negative sign for this square root. We consider only positive sign. Okay, here I got the length of the hypotenuse OB over here, that is 2. And also this 2 is the radius of the circle because this OB is the radius of the circle. It connects the center of the circle and a point on the circle. Okay, here I got the radius of the circle 2 and the length of OA also here is 2 because this one also is radius. Okay, now let's consider the right triangle OAB over here. In this right triangle OAB, we have the lengths of all the three sides, 1, square root of 3, 2. And we know that in any right triangle, the hypotenuse is the longest side. Okay, so comparing these three values, 1, square root of 3 and 2. So we know that square root of 3 is 1.732 approximately. So clearly, this 1 is the smallest of all these three values over here. So the OC is the shortest leg of this right triangle. Okay, and also in this right triangle, the length of the hypotenuse is 2 times the length of the shortest leg. And also when I consider the other leg, it is square root of 3 times the shortest leg. There is square root of 3 times 1 is square root of 3. This is the length of this leg. In any right triangle, if the length of the hypotenuse is 2 times the length of the shortest leg, and also the length of the other leg is square root of 3 times the shortest leg, then this is a 30, 60, 90 special right triangle. That is, we'll have the interior angles of 30 degrees, 60 degrees and 90 degrees. Okay, here we have the right angle, that is 90 degrees. And the smallest angle, 30 degrees, will have opposite to the shortest leg of the right triangle. Here OC is the shortest leg. Opposite to this, we'll have the smallest interior angle measure, 30 degrees. So here we have 30 degrees. So another interior angle, 60 degrees, will have over here. Okay, now let's consider this right triangle OAD over here. In this right triangle OAD, to get the length of this leg, this horizontal line segment OD, we have to consider the x-coordinate of this point A, that is square root of 2. So the length of this leg OD is square root of 2. Now to get the length of this vertical line segment, that is the leg AD of this triangle, we have to consider the y-coordinate of the point over here. Since we consider the length of this leg AD, we have to consider this y-coordinate over here as a positive value. Then we get square root of 2 as the length of this leg AD. Okay, in this right triangle OAD, two legs are equal in length. Since two legs are equal in length, it is an isosceles right triangle. In any isosceles right triangle, apart from the interior angle measure 90 degree, so in the remaining two interior angles, each angle will measure 45 degrees. So here we'll have 45 degrees and here we'll have 45 degrees. Okay, let's consider the angle measure over here. So this is the angle between the x-axis and y-axis. Always the angle between x-axis and y-axis right angle, that is 90 degrees we have over here. And what is the measure of this angle? So we know that here we have a right angle. In this right angle, we know that it's 60 degrees. Then the measure of this angle has to be 30 degrees. Okay, now our aim is to get the central angle of the sector, that is a shaded region. For that, we have to add this 30 degrees, 90 degrees, and 45 degrees. Okay, now let me add them. 30, positive 90, positive 45 equals to 165. So the central angle of this sector, the shaded region, is 165 degrees. Already we got the radius of the circle, that is 2. Okay, now we can find the area of the shaded region. Okay, let me write the stuff over here. That is the area of the shaded region. Let me write it over here. Area of the shaded region equals to, the formula is, area of the shaded region is the sector. The formula to get area of the sector is theta divided by 360 degree times pi r square, that is area of the circle. Here theta is the central angle of the sector, that is 165. Okay, let me plug in 165 for theta divided by 360 times pi times r square. Okay, here this r is the radius. We got the radius of the circle 2. Okay, let me plug in 2 for the radius r, that is 2 square. Okay, 165 divided by 360 times pi times the value of 2 square is 4. Okay, here 4 goes into 4 1 times and 4 goes into 36 9 times. We can take this 0 over here. And the greatest common divisor for 165 90 is 15. That is 15 goes into 96 times. 15 goes into 165 11 times. So we get 11 pi in numerator and 6 in denominator. Okay, here I got the area of the shaded region, that is 11 pi over 6 square units. We find this 11 pi over 6 in answer choice D. The correct answer choice for this question is D.